right, so this is day 1 notes, and we're going to be focusing on shifting, reflecting, and stretching graphs. And we're looking at a graphical and an analytical approach, so graphical and using also algebra. So in this class, you really want to make sure that you read the directions, and I would encourage you to circle verbs. They create your to-do list, and then if you underline items that you need to pay attention to. So here it says many functions can be graphed by simply knowing the general shape of basic graphs of functions and understanding what effect adding and subtracting and negating certain parts of the function have on the graph. So we're supposed to graph each of the functions below on the graphing calculator. And in this class, when I want you to use a graphing calculator, I want you to use the free one at Desmos. And then we're going to state how the change in the equations from graph B through I affected graph A. So let's take a look and see these specific graphs. So you have your basic square root function, which is radx. Pay attention that we start at 0, 0. We've got the ordered pair 1, 1. And then as the x's go farther out, you're going up 1 unit. So for example, when x is 1, the square root of 1 is 1. When x is 4, the square root of 4 is 2. When x is 9, you're going to be at 3 and so forth. So it's got this kind of curve. If you are adding 2 on the outside or adding anything on the outside, it's going to be located here, or it's just the constant, which just is going to affect the y values by going up 2 from every existing point. Now we're going to subtract 2 and we're going to go down 2. And if we take a look at our ordered pairs, you can see that the parent was the original 0, 0, 1, 1, and 4, 2. And then now the ordered pairs are 0, 2, 1, we're going to add 2, so 1, 3. And then we've got 4, 4. All right, so when we shift down, that 0, 0 became 0, negative 2. The 1 we are subtracting 2 from, so 1, negative 1. And then we also now have 4, 0. So now let's take a look at the effect when it's dealing with on the inside. So anytime when you have the inside, you want to set whatever's on the inside equal to 0 and solve for x and then analyze what this is saying. So this is saying that we're going to go left 2. Here again, we're going to set this equal to 0 and it's a positive 2, so we're going to the right. This one we are dealing with outside. So again, anything on the outside is going to affect the y coordinate. And so what we're going to have is the rad x, and now the y's are now, instead of being positive, they're negative, which means it's going to reflect. So this is how we are going to indicate that change. Okay, shifting left 2, right 2, and reflect on the x-axis. When you are done, you go back up, make sure that you graphed each of them, put a check mark when you're done, and then you also stated the change and put a check mark. So again, you don't overlook anything. Now let's take a look with G, H, and I. Here we're supposed to be multiplying the outside by 2 and multiplying the x by negative 1. And the reason why is because look at our value of x. The idea of anything on the inside of a function is to always take it back to x. So if I gave you any function and I said x plus 3, well, really what we're trying to do, and this is what we are thinking, right? X plus 3 plus what is going to take it back to 0. So that means that we're going to have to subtract 3 so that we are left with, actually we're trying to take it back to x. So we're trying to undo everything. So that means we would have negative 3, which is why we would be moving left 3. So if I said f of negative x, what now do I need to do in order to undo this negative? Well, then I would need to multiply by a negative so that I could actually get back to a positive x. So that's why the x values are going to be multiplied by a negative. We will get into that more as we go. So if I take a look, let's analyze what this is saying. So we've got the 2 on the outside, which is a vertical stretch by a factor of 2. And then this negative, so like the x's are now negative. So originally when the x's were on this side, the opposite x's are now on this side, which is why it looks like this. And it's a reflection in the y-axis. So again, the negative on that is affecting the x is going to be reflecting the y. And if you have a negative on the outside, it is going to be a reflection over the x-axis. And again, we'll do more problems with that later. So let's take a look at this. We're going to multiply the x by -1 and subtract 2 on the inside. So basically what you can see here is there's 2 techniques. You can take the inside and set it equal to 0, and this is going to give you your shift, okay? When you do that, you can tell that you are going left 2 units. The other thing I need you to be aware of is this negative. I would love for you guys to be able to factor out the -1 so that you can see that it's a reflection across the y-axis, and then you are much more easily able to identify the fact that we're going left 2. So here, let's factor out a -1 and rewrite it as x minus 2. So this -1 is a reflection across the y, and we are going 2 units to the right. So on this particular set of problems, we were supposed to predict how the graphs would be different from the original parent. We were going to state the changes, and then we were going to state the domain and the range. So in class, I wanted you to talk to your partner. Now we're doing a vertical stretch by a factor of 2. That's what the 2 is. We are going to reflect the y-axis because you can see that there was a negative here. I rewrote the equation so that I could quickly identify that. So we have a vertical stretch by a factor of 2, a reflection on the y. We have right 1, and then we have down 3. And I tried to color code. The yellow is going to represent the change in the y. So 2 times y minus 3. So the shifts are always adding and subtracting. And we always do that last in terms of PEMDAS. Reflecting is going to be multiplying by a negative. And then we are going to go right 1, which means we're adding 1. So this is what I need you to be able to generate from the changes that are occurring. So now we have, if you take a look, we had our original parent points. So these were our parent. And then for every x, I'm going to multiply by a negative and then add 1. I'm going to multiply by a negative and add 1. Multiply by a negative and add 1. Multiply by a negative and add 1. For every y, I'm going to multiply by 2 and subtract 3. All right, so that's how I generated these y values. Looking at the graph, the domain, -infinity, and you stop at 1. I am including 1 because this is a closed dot. The range is from the bottom up. -3 is the smallest y value. I include -3, which is why it's bracket. And the y values go on up to infinity because this constantly is going up. So let's take a look at this one. The negative on the outside is the reflection against the x. The +3 is up 3. We are setting the inside equal to 0 to determine the shift, which is right 1. Again, we're taking this language and we are generating the changes to the coordinates. The blue represents the change in the x, which is how I'm getting my x, and I'm supposed to add 1. The yellow represents the changes to the y, so it's -y plus 3. I'm making all of those changes to the parent. I generate these new points, and I plot them. The domain is from 1 to infinity, and then -infinity to 3 would be the range. This is a basic kind of rule of how we are going to change those coordinates based on what's happening. So you can see this is shifting up and down, which means we're changing the y coordinates like this. Here we're going left and right, And notice how we're changing the x coordinates based on the work here. This is a reflection. This is a reflection. Notice which ordered pair it reflects. This absolute value might be a little bit new to you, but basically what it's saying is all of the y values that you generate are going to be positive because we're taking the absolute value of any y value. So that's what it would look like. And then a times the function is going to be a vertical stretch by a factor of whatever a is. And all that means is that you're going to be multiplying the a times the y. Think about f of x as another way to write y. All right, so these are your parents. Make sure you have these correct points. This is your parabola. This is an absolute value. This is the cubed root, so make sure that these points are there, and this is how you connect them. And then this is cubed, so please make sure these points are there and you connect them. Now let's take a look at the descriptions. It's very important that you try this on your own and then check with the video. So here, again, anything that is affecting the x is going to be on the inside of the function. So we are going left 2 and we're going down 3. I've color-coded so that you can see how we are affecting which coordinates. And then these are the parent that you always start with. Affect the changes, and here you are. Same thing. So you'll see that I color-coded, created the change to the ordered pair, and then these again are the parent. And then we're changing our parent graph points to include these changes. Same thing here and here. So please let me know if you have any questions on that. And then now we're going to day 2 notes.